Can we start, sir?
Yes, ma'am, we can start.
Yes, sir. Thank you. Happy morning to all of you. Sharing knowledge is not about giving people something or getting something from them. That is only valid for information sharing. Sharing knowledge occurs when people are genuinely interested in helping one another to develop new capacities for action. It is about creating learning process. So on behalf of Department of NCA, SRM Ramapuram, I welcome you all for this wonderful knowledge sharing session 6. You all gathered here for 6th day of International PDP program on data science, a revelation of the modern era. Now, I request Dr. S. Uma Shankari ma'am, Assistant Professor, Department of MCA, SRM Ramapuram, to introduce today's guest speaker, Dr. Assistant Professor, GSFC University, Gujarat. Please, ma'am.
Thank you, ma'am. Ma'am, am I audible?
Yes, ma'am, you're audible.
Thank you, ma'am. Yeah, actually, initially, sir, when we prepared the invitation, sir was in GSFC College, but he's in International College of Engineering Management, Muscat. So I just wanted to mention that. I take immense pleasure in introducing our chief guest, Dr. Ajit, Assistant Professor, Department of Fire and Environmental and Safety Engineering from International College of Engineering and Management, Muscat. Dr. Ajit obtained his MTech degree from Anna University and doctorate from Kalasundaram Academy of Research and Foundation. Dr. Ajit served as a panel member to set up Industry, Fire and Safety Lab in collaboration with Airport Authority of India, Vadodara, when he was in the GSFC University during the academic year 2021-22. He also acted as a program coordinator and committee member in introducing the various UG and PG program, especially in the area of fire and safety at GSFC University, Gujarat. Added to his credit, one of his research article entitled A Review of Hazard and the Consequence in Firework Industries has been highlighted in the first issue of SN Applied Science Journal, Editor's Choice, indexed in Scopus, ESI, in 2018. He is a reviewer in various international journals, which is indexed in Scopus and ESI. His total citation has been reached to 150 till date. Dr. Ajit has received the Best Receiver recognition from International Journal of Construction Management, which is indexed in Emerging Source Citation Index and Scopus in 2021. He also won third prize in poster presentation on the topic Analysis of Risk and Human Error in Firework Industries at Indian Institute of Technology, Gandhinagar in 2017. His software proficiency includes NeuroShell, genetic programming, and ePanels. His research interest makes him to explore applications of data science in construction engineering, fire and safety, industry safety, to name a few. We're extremely happy to have such a versatile personality amid us today. Thank you, sir, for accepting our invite and being with us today. Sir, I invite you to address the gathering.
Thank you, madam. Thank you so much for the brief introduction. I hope I am audible. Hello. Hello.
Yes, sir, you are audible.
Okay. So shall I start now?
Yes, sir.
Okay. Thank you so much, and good morning, one and all present there. So let's start the session. So my topic, which is given to me, is application of machine learning tools in industrial engineering, a case-based study on Indian construction industries. So this is a synopsis. You cannot, find the exact topics in the slides, but those are something relevant to this synopsis. So first will be basic introduction to construction industries, which we should know about. Then application of coherent architecture, application of backpropagation neural network, and application of genetic programming. You all are computer people. You might be knowing, in depth of about this, but I'll be telling about the application of these machine learning tools and how it is used in industrial safety engineering. So brief introduction about construction industry. As you know, and I'm going to talk about only the Indian scenario of construction sites, not the overall scenario. So it is next to agriculture in India that as it offers a huge number of employments for both male and female workers in India. So here the nature of construction site, the activities that is taking place or the process that is involved in the construction site is highly hazardous. Why we call it as highly hazardous means, there are a larger number of parallel activities that is taking place in the construction industries or in the construction site. Some of those I have mentioned here. That is, workers will work with heavy equipments, workers will work with rotating machineries, and some moving vehicles will be there. Height work will be there, hot work will be there. So there are multiple, different sort of activities or process that is happening in the construction site. So we are calling it as hazardous industry. So these are, not only the introduction, but this is the need for machine learning tools in construction industries. So that we'll be seeing that. So also Indian construction industries contribute 9% of country's GDP when compared to other things. Also, the globally the fatality rate of the construction workers is twice, and the injury rate is twice as higher than other workers in other industries. So this is also some of the need for this study. These are some of the accident scenarios in construction sites, in Indian construction sites, basically. So here, the source, I have collected this data from Indian newspapers. Here you can see the nature of accidents. There are different sort of accidents that occurred in Indian construction sites, as well as some people have got, or some workers have got died, as well as some workers have got injured due to this accidents, and the places have been given. So this is also a necessity thing. This statistical data help us that we need some different things to reduce the accidents or to mitigate the injuries in the particular construction sites. That is a basic idea. So I have two different cases to show you how the usage of machine learning tools has been adapted in this studies. So case one will be allocation of workers using a task personal nexus matrix. Here we have been, I have used three sort of machine learning tools that we will be learning that. This is a methodology of case one. So initially collection of data is very much important. Collection of reliable data is very much important. So that we have collected in a South Indian, construction site, one of the construction site. So here we have collected basically the age of the workers, experience, education, competency level, type of accident, and safety knowledge of the workers. So in this, first of all, we are going to determine the safety performance of the workers. So after performing the safety performance, we can assign the particular worker to the particular task, so that we can minimize the hazard, we can minimize the injuries, as well as we can minimize the accident. So that is the basic idea of this, case one. The second step is, level two is supervisor's assessment. Here, the performance is assessed using the basic guidelines, hidden rules, because we need some experimental value in order to, ensure with the machine learning tools, the output which we are getting from the machine learning tools, that is, measuring the performance using the basic guidelines. Level three is classification of those data. So here we have nearly, collected 130 data. Yeah, around 130 data. So the level is set into three different parameters. One is high level performance, medium level performance, and low level performance of the workers. So here we need to classify the data into three different sets. That may be high level of the workers, performance, high performance of the workers, medium performance of the workers, as well as low performance of the workers. But the classification can be that depends upon the user. How many classification if you want, then we can classify accordingly. Here I have went with 3 different classifications: high, medium, and low. Level 4 is that prediction of safety performance using artificial neural network, that is back propagation algorithm. So for each classification, we have developed an ANN model. That is a basic concept of this. These are some of the methods. I'm not going in depth, as it is very much poorly related to industrial safety engineering. But still, if you want to understand the overall picture, we have to know some basics of this method. That is my idea. So here we have 2 different methods. One is HIRA technique, from which we can determine, or from which we can arrive the high hazardous zone, the different zones of the particular construction industry. How many tasks will come under high zone, how many tasks will come under medium zone, and how many tasks will come under low zone. So here we have taken 15 different activities of the construction industries, say excavation, height work, hot work, transportation, and so on, material handling, and so on. So 15 different tasks are there. Yes. Okay. Then the second technique is hard technique. So here we can able to determine the human error probability of the particular task in which the worker is working. So we have 6 different steps in that particular hard technique. So in the third step, risk come human error, that is RHT, which is the proposed method by integrating the safety performance of the workers, by which we have got from artificial neural network model. So there, I have integrated both the thing, the task as well as the human error. So risk come human error, that can be calculated using the formula PORI into HEP. That is, the data which is the result which we have got from HIRA technique into the data which we have got from hard technique. That is the overall risk come human error. This is the Cohen algorithm, which is used for classification of data. So here we have 130 data, and we have classified into 3 different sets. That is, high, medium, and low. So in order to calculate or in order to determine the performance of the workers, I have did it. So Cohen algorithm is basically unsupervised algorithm. That you might be aware of that, but here we have only 2 layers. One is the input layer and another one is the output layer. W is the weight that is given for each input layer. Here in this case, I have 6 inputs. That's why the input layer is 6, and we have 3 different outputs, low, high, and medium. That's why the output layer is kept as 3. There are different types of unsupervised learning system. So as self-organizing feature maps, adaptive resonance theory, and competitive learning. But still, many researchers have identified that this, Cohen neural network or Cohen algorithm has been highly efficient when compared to other techniques in industrial safety engineering, basically in industrial safety engineering. So that is a basic, idea of Cohen algorithm. So this is the data pre-processing. As I have said that we have 6 different inputs as age, experience, education, skill, accident, and safety knowledge. This is a questionnaire survey. The data has been collected through a questionnaire survey of the workers, and the questionnaire survey is a little bit we made that as an easy task to the worker, so that he or she can able to fill the data with some interest. That is a basic purpose. So for each input for each question in the questionnaire survey, we have 3 different levels. So for example, if it is age, then the levels will be 3, whether it is less than 25 or greater than 50, as well as 25 to 50. Then the level is set as 1 to 3 in order to feed the data into the artificial neural network model, in order to evolve the model much efficiently or easy. That is the thing. So in the questionnaire survey, we will be having only the inputs as well as the frequency. The levels we have been, we have been fed for that particular software. Then the same thing, that experience, education, skill, everything we have a different level of different frequency level, as well as we have set up level for the same. So in order to calculate the experimental data or in order to know the actual performance of the workers in the site, we have been used if-then rules, and we have consulted the safety engineers and as well as the safety supervisors of the particular site in order to rank them accordingly. So I'm just explaining the first one. So if the input or I1, that is age, if the input is 1, that is medium, low level, as well as the experience is low and the education is medium, and I4, that is skill, the skill is low, as well as the accident is high, and the safety knowledge is low, then the performance is low. So like this we have developed around 9 to 10 actual performance in order to determine the safety performance of the workers. Then classification of data sets using Cohen algorithm. So here we have different classifiers as well as different parameters that particular machine learning tool in order to classify the data sets into 3 different criteria. So set 1 is actually low level. The workers who has the low level performance will comes under set 1. The set 2 is medium level. So the workers who have a medium level performance will come under set 2, and set 3 is a high level. Oh, sorry. Set 3 is low level. Set 2 is medium level, and set 3 is low level. That is a high level. That is the difference. So set 3, 53%. 53 workers has lower performance in the particular site, 24% has medium performance in the particular site, and 23 workers has higher performance in that particular site. That is the overall idea of this Cohen algorithm. So these are the results that is obtained from Cohen algorithm. So in order to achieve this result, we have run the particular Cohen neural network with the initial weight that ranges from 0.5 to 1. So we can change that if we didn't get the results properly or more accurately. So the learning rate is also from 0.5 to 1, and as well as the neighborhood from 0.5 to 2, and it captures the number of cycles in which the Cohen network has been run, that is from 50 to 60. So these are the basic parameters that is set in the Cohen algorithm to get the results approximately or accurately. So there we can able to see that first cluster forms about 23% of the data, and that is the higher performance of workers. Then 24% of the data in the second set with the medium performance, and 53% of the data in the third set, that is a lower performance. So here the parameters have been given equal weightage. Illicit and distance based approach is seems to be appropriate, so that we can get some results more accurately. So the final run, final data classifiers is neurons with 3, learning rate with 1, initial weight with 1, neighborhood and epochs as 0.5 and 50. We have got the results. We have got much good results in this Cohen algorithm. Then coming to back propagation neural network, that is, after classifying the data in the Cohen set, we have used back propagation neural network in order to model those classified data. So here you can see that back propagation neural network has 3 layers as input layer, hidden layers, and output layer. So each, neurons are interconnected with each other to form the architecture. That is the general thing. So here, in order to get the results or in order to get the BNN model, the data has to be tested. The data has to be trained, tested, as well as validated to get the existing output. So here also we have did a small research in order to find the most suitable method for safety engineering in order to solve the civil engineering problems. There we have found that BNN or back propagation neural network that is due to its high accuracy, the results are also good in this model. So we have been used the same thing. So generally, performance of this type of models can be measured using mean square error, absolute error, percentage error, mean absolute percentage error, correlation coefficient, and so on. There might be some different performance measurement model also. But we have adopted a different thing. We have went with the number of hits that what will be see for to measuring the performance of the model. Because we didn't go with this mean square and absolute error. We didn't go with this traditional method. We have went as this is an safety engineering problems. We went something in a different way. Coming to predicting the safety performance using BNN algorithm. So after classifying the data sets into 3 different sets, we have developed 3 different models for the same. So for each cluster, the algorithm is applied individually to create 3 different models. That what we have said or seen. So the output from the network is discrete with 3 possible choices. That what I have explained, that is low performer, medium performer, as well as high performer. So here you can see that in cluster 1, that is in classification 1, the training number of training set is 10, and number of testing is 8, and number of validation, number of data is 5. So here as a performance measurement, we have went with the number of hits. For example, if in the training set, if the number of data is 10 and the number of matches is 10. So here we have seen the matches, how equally the experimental results as well as the model results have been matching. As it is a safety related, safety engineering related problem, we cannot get the intermediate number. So we need some discrete number so that we can tell whether the particular worker is or the particular activity is safe or unsafe. If it is safe, then we'll be getting the number hit as 1. If it is unsafe, we'll be getting as 0. So that is the basic idea we have obtained here. So in the case 2, the same thing. If it is the number of data is 12 in training, but the number of matches is 11, and in testing it is 7 and number of matches is 6, and in validation it is 5 and 4. So here we have tried to obtain 80% of the results, as the number of data sets in the validation is low. It is only 5. So if we get 4 number of equal matches, then we said that the model is little bit okay. So error measure, as I have said, that number or percentage of exact matches after rounding of the network output to the nearest integer. That is the general thing. Then here we have also studied with genetic programming how artificial neural network and genetic programming works together in this particular case one. These are this is the basics of genetic programming. Might be knowing fully, but it's my duty to give a brief on GP as well. So basically, GP works on the principle of Darwinian theory of survival of fittest. So the classifiers or the parameters which is used in ANN as well as GP has a lot of difference. But although it can solve nonlinear regression problems, but still the classifiers and parameters which we are using in both the machine learning tools has a bit different thing. So in GP we have different parameters such as crossover, mutation, and fitness function in order to solve any sort of problems. So in GP we have a different set of functions, that is addition, subtraction, multiplication. So these are the things which is basically focused on software science. So the most commonly used primitive function for basic engineering problems can be arithmetic and mathematical function. So the output which we which we can obtain from the GP model will be in the form of equation. But in ANN we cannot found any equation type of output. We will be getting the experimental values. What are the values we'll be giving? We will be getting that as output. But here in GP we will be getting the output in the form of equation. So if we solve the equation, then we will be getting the output. Then we can match the experimental results. So this is about GP run. Here we have in artificial neural network, There we have given the number of runs, number of epochs, initial weight, neighborhood, and so on. But in equations, but in GP, the parameters will vary from population size, mutation, crossover rates, number of generation, and program size. So that are the values. So we have been changing the values in order to get the effective results. So these are the three equations which we have got from genetic programming model. So for higher performance, we have got safety performance one. That is just an indication to understand. So that is 4.05 minus 0.98 into V4. For medium performance, we have got again another equation that is little bit big when comparing to high and lower performance, but still it is found okay. For lower performance, we have got another equation V2 into 1 minus 0.02 into P4Q. So from this, all the three equations from high, medium, and low equation, we can find the variable as V4. V4 is common in all equations. So that that indicates the safety performance of the workers basically, because as it is coming in all the three equations. Which depends on the historical account of accidents there. So the variable V4 is related to the input data, which is from I1 to I6. So there V4 is related to number of historical accidents that the worker has been done. So from this we can get an overall idea or conclusion that the safety performance of the workers has been fully depending upon the historical accidents that he or she has been done in the past. Past in the sense, that also depends. So if you are determining the safety performance of the same workers for 3 months, then we'll be going for 3 months data. Or else if you are going to determine the safety performance of the workers for the past 6 months or 1 year, then we have to collect the data accordingly. So the results are here, the results are based upon 3 months data. Final thing is risk, human error and risk range. So first we have seen two different methods. One is a HIRA technique and another one is human heart technique to identify the probable human error. So this is for task one, that is excavation, and we have separated different activities. And the human error has been identified as a human error probability from method 2. Risk range is obtained from method 1, and RHC condition, that is POR, has been calculated by using HEP into risk range. That is 1 into 36 is of course 36. This is, as I have said, that we went for 15 construction activities, and we have found human error probability as well as risk range. And this is the RHC condition for all the 15 tasks. Yeah. So here the red color indicates that the RHC condition is high and it is too much hazardous, and yellow it is low, and green it is medium. So then finally coming to allocation of workers using a task personnel nexus matrix, we have taken 15 different activities, and we have split a different risk level for those things. So if the RHC level is below 5%, then the risk level is low. If it is 5 to 15%, it is medium, and if it is above 15%, it is of course high level. Then now we have to allocate the workers in order to reduce the accidents or injuries to the workers. So if the RHC level is low, then the list of tasks is from T5, T7, T8, not consequent tasks, but if the RHC level is below 5%, so those tasks is coming under this RHC level. So there we have nearly 8 number of tasks, and the total number of workers allocated is 27. That is a low performance worker. So if the worker's performance, or if the worker who is falling in this low level category, he or she cannot able to perform any activity in medium or high level task, because he is having only the low performance, so he cannot go to another, or we cannot allocate him to another level of task or process. Then if the worker who is having a medium level performance, that is nearly we have 4 tasks, and but the number of workers that is allocated there is 51. So the medium level workers can work in medium level task as well as low level task. That is a basic idea. And high level task is 3. We have a 3 number of tasks, and the number of workers allocated to that is 22. So if he or she is a high level performer, performer, then he can able to, or we can allocate low, medium as well as high level tasks, because they might have awareness about the hazards, and they might have attended some safety meetings and so on. So by this way, we can allocate the workers using task personnel nexus matrix. That's all about case 2. Now coming to case 1. Case 2 is predicting safety performance of construction site. So in case 1, we have seen about safety performance of the workers, how to determine the safety performance, what are the data that is collected, and how we can allocate the workers to different tasks. But in case 2, that is also a bit same, but the data collection and the methods that is used, that you can see the difference between both the things. Because in case 1, we went for the workers, and case 2, we are going to see about the overall industry. So this is the methodology for case 2 in order to determine the safety performance of a particular site. First thing, we know that about identification of modeling parameters. Here we'll be collecting the questionnaire survey. Basically, collection of data will be taking place. So here some sort of data has been collected using a questionnaire survey. Some sort of data has been collected using direct interviews with the workers, with the safety supervisors, with the engineers, and as well as with the project managers. And some sort of data has been collected from the recorded data in the field. So here also we have kept the data processing as simple, data scale as simple as from 1 to 3, so that the processing time that is used in the software will get reduced. That is the basic idea. Third step is selection and change of modeling tool parameter that is happening, which will happen in the machine learning tools. So each machine learning tool has a different a parameter or different criteria in order to obtain the suitable results. Step 4 is converging the model training through error measure. We have seen different error measure, but we have adapted the number of hits as error measure as safety engineering is concerned. So if the particular model satisfies the requirement, then it is okay. So or else if it is not satisfied, then we have to change the modeling tool parameter, and then we have to convert the model training through error measure. That is a basic idea of this methodology. Here in this survey, we have collected data from 120 workers. So here also we have kept the questionnaire in a simple way, so that the workers can able to understand such things easily, as well as they can able to complete the questionnaire survey within a short period of time. So here the first part of the questionnaire consists of name, age, and experience of the workers, as well as the second part, which consists of frequency toolbox stop, safety supervision, safety training, availability of personal protective equipment in the site, and as well as the usage of personal protective equipment in the site. So this is about the first part of the questionnaire survey. As I have said that some sort of data has been collected from site data book, that is type of accidents that is occurred in the particular site, as well as the competency level of the workers. So here in the competency level of the workers, that has been given by the safety supervisor who is supervising the particular worker. That is the thing. So after collecting the data, as well as after setting the inputs for our study, two safety engineers as well as a project manager has also been consulted in order to discuss about the parameters that has been adapted for the questionnaire survey, as well as to check the efficiency of the particular data. This is about data pre-processing, the same thing, but here we have different inputs as well as we have a different sort of frequency. So toolbox talk is nothing but a talk that is given to the workers prior to the work, before to the work, so that the workers can get some awareness about the work or the process that he is going to work in the particular site, in order to reduce the injuries or accidents. That is the basic purpose of this toolbox talk. So there we have 3 different levels of frequency. If the toolbox talk is given very much rarely, then the level will be 1. It is given occasionally, then it will be 2. Or else if it is given every time before the starting of the task, it is given perfectly in the starting of before the starting of the task, then the level will be 3. So the same, as well as for safety supervision, safety training, PP availability, PP usage, types of accidents, as well as for competency, different frequencies has been set and the levels has been, determined from those frequencies. This is a brief about the data pre-processing for this case too. So then coming to the actual performance of the site, we need some experimental data in order to, correlate with the models which we are going to obtain. So for that, if then rules has been found, or if then rules has been framed. So let me explain the first one. So if the frequency of toolbox talk is low, or if the safety supervision is low, in that case 1 in ANN, we have been seeing about we have been seeing in the number format. The same thing here, but in order to make you better understand about the if then rules, here I have given in a theoretical manner. That is the thing. The safety supervision is low and the safety training is low. The availability of personal protective equipments, say safety helmets, safety gadgets, eye protection, hand gloves, mask, and so on. That if it is low, if the personal protective equipment usage is low, type of accident is low, and the competence of the worker is low, then the performance of the site is naturally low. Here we are focusing on the workers as well as the site, because here our main intention is to determine the safety performance of the construction industry or construction site. So like this, we have framed the if-then rules, different set of if-then rules in order to determine the actual performance of the particular construction industry. We have given different conditions of the models in order to check the ability of the particular machine learning tools which we are using here. So in order to determine the safety performance, here I have used ANN, I have used GP, as well as I have compared it with our traditional nonlinear regression model, nonlinear regression tool. So here in ANN, the inputs we have 7 different inputs, from frequency of toolbox talk to competency of the workers. So in ANN, when we are feeding the data, the inputs will be from I1 to I7, I1, I2 to I7. It can go up to a number of inputs as what we need or what we require. But in GP, the inputs start from I0 to I6. It is not this. 1 minute. So these inputs, won't make much difference in the results, but that is based upon the tools which we are using. That is the main thing. 4 conditions has been used to check the ability of the machine learning tools. So condition C1 will indicates that it is used to check the ability of the tool to extrapolate the validation set. So in this case also, we have 3 different classifications. So we can classify the site as a low performance site, we can classify the site as medium, as well as we can classify the site as higher performance site. But in the case, C1, if it needs to extrapolate the validation set, the higher and lower performance will be given, the medium and low performance will be given in the training and testing set, and it has to validate it has to extrapolate the data in the validation set. That is a basic idea. In condition C2, it has to predict the lower performance in the validation set. In that case, higher and medium performance is given in training and testing, and in the validation set, it has to predict the lower performance data. In condition C3, it has to predict the medium performance. So in that case, lower performance and higher performance will be given in training and testing data, and in the validation set, the model which we are going to evolve has to predict the medium performance of the data. And in condition C4, it has to predict the performance of the mixed up data. So mixed up data will be given in training, testing, and in validation. So in order to check the efficiency of the machine learning tools, this condition has been given. Non-linear regression. This is a basic model, and in order to evolve the model, we have used Minitabs. That is a very conventional tool you might be knowing. So this is a statistical tool which is used to model the relationship between both dependent and independent variable if by any. So here also the output we can get in the form of equation. This is a general nonlinear regression equation. This can be used for prediction as well as forecasting. So these are the results that which we have obtained from nonlinear regression. We have got two different equations for 4 cases. So equation 1, that is this big equation, equation 1. So this is applicable for case 1 in order to predict the higher performance data sets in validation level. For case for case 2, case 3, and case 4, this equation is applicable. So when we are feeding the data of different cases, we have got the same equation. So in nonlinear regression, we have got only 2 equations. For case 1, this equation 1 for case 1 and equation 2 for C2, C3, and C4. So here the overall exact matches. Here also we have went with the exact matches or the number of hits, what I have said earlier. The overall exact matches for C1, that is for case 1 is 60%, and for C2, C3, and C4 that we have found, we have got only 50% of the results. This is a model which is developed using artificial neural network. Here I don't have any theoretical explanation of ANN. It is same what which is discussed in the previous one. Here we have 4 different conditions, that is C1, C2 up to C4, and here the data sets, training, testing, and validation, which will be using for both ANN as well as GP. But in in NLR, that is nonlinear regression, we don't have those things. If you feed the data, and we'll be clicking some inputs, and we'll be getting the outputs. So here the training set, in the training set we have 10 data and the number of matches is 9. Here it is a percentage. That's okay. Here in 8 hidden neurons we are getting, or we are achieving this number of matches. That is the main thing. And in testing we have 7 number of data and the total number of matches is 5 and the percentage is 51. And in validation the number of data is 5 and the number of data is 5 and the number of matches is 1. And the percentage is only 20. The result we have got with 8 hidden neurons. So likewise we have did for case 2, condition 2, condition 3, and condition 4. In condition 2 validation, in the validation set we have 60% of the exact matches. In condition 3 we have got 100% of the exact matches, where the number of data is 5 as well as the number of matches is also 5. But in condition C4, we have got 5 data and 4 number of matches, so the percentage is 7. In for condition C2, C3, and C4 with hidden neuron 7, we have we can able to achieve the results. But ANN fails to predict the higher performance, to extrapolate the data sets, as well as it fails to predict the medium performance of the data sets. That's what here we can see, because in C1 we can get 20% of the exact matches, and C2 we can get 60% of the exact matches. In C3 it is 100 and C4 it is 80. That is okay. So validation set we have only 5 number of data. Then with the same data, we have obtained the model using a genetic programming that we have got GP evolved equations. And here we have used disabler software to evolve GP equations. So the same thing, same conditions, which we have seen in ANN also. We have 4 different conditions, and here in condition C1 we have 3 number of matches for total of 5 data, that is 60%. Here we have 4 number of matches, 80%. In condition C3 we have 5 number of matches with 100, and C4 it is 4 number of matches with 80%. So if we solve this, after feeding the data into GP and genetic programming, then we'll be setting different parameters. Then we'll be obtaining this equations. So after decoding this equations by giving the input values, we can get the outputs as desired. These are the comparison of results of nonlinear regression, genetic programming, and artificial neural network. In condition C1, we can see that ANN is a little bit small. I don't know about that, but still, ANN is a little bit small in that. In condition C2, genetic programming leads that condition, but ANN is almost 60%. NLR is a little bit in a smaller end there. In condition C3, genetic programming and ANN has achieved 100% of the exact matches, where when comparing to NLR, it is around only 50%. In comparing, condition C4, we have 80% of the exact matches in ANN as well as GP. But when comparing to that NLR can able to achieve only 50% of the results. So yeah, these are something about application of machine learning tools in industrial safety engineering. I didn't went much in depth about the theoretical definitions as well as the theoretical things of ANN Cohen network, as you are computer people and you might be aware about that. So that my intention is to show that only the application of these machine learning tools in industrial safety engineering. So that's all from my side. So if you have any questions, you can ask. As well as I'm open to research in the field, because I'm an young researcher who is working in the same field. So it is also possible if anyone needs me there. Thank you so much from my side. Over to the convener.
Participants, if you have any queries, you can put it in the chat box, or else you can unmute yourself and ask your queries.
Sir, good morning, sir.
Yes, good morning.
Sir, as far as the two techniques, artificial neural network and genetic programming is concerned, you said that you are using machine learning techniques. So ANN can be considered as the end of ML and start of DL. Of course, the definitions keep changing, but this is the definition that I heard. But will genetic programming come within the scope of ML or DL, sir?
As of my knowledge, it can be also said as machine learning tools, because I have been referred several research articles, so I can also say that it can also come in ML.
Okay, sir. Thanks for the clarification, sir.
Any other queries? Dear participants, you are requested to fill today's feedback form. It is in the chat box. Kindly fill it. If no queries, I think, sir, we can conclude the session, sir.
Okay. So first of all, my hearty thanks to the management of SRM Institute of Science and Technology, who have given me this opportunity. Secondly, I thank the organizing secretary, Dr. Dileepan sir, Professor and Head, Department of MCA. Also, I thank the conveners who are behind the scene for organizing the 2 weeks professional development program. Thank you for inviting me, and thank you for giving me this opportunity. Thank you so much.
Thank you, sir. Thank you much. Really, we had a wonderful session with you. Thank you for accepting our invitation and being here with us today.
Yeah. Thank you. Thank you so much.
And also, I would like to express my sincere gratitude to our management for giving permission to conduct this knowledge sharing program. And also, I would like to convey my heartfelt thanks to our Dean Sir and Vice Principal Academics Sir and our Head of the Department, Dr. Dileepan Sir, for encouraging and supporting us to conduct this kind of knowledge sharing sessions. Finally, I would like to express my sincere thanks to all participants who have spent her valuable time with us. Thank you all. Thank you all for your presence. Thank you so much. Participants, kindly fill your feedback.
Can I leave, ma'am?
Yes, sir, sure.
Okay,
Thank you.
thank you.